Let's revisit the string methods we looked at before in light of Liskov's categories. We already figured out that since strings are immutable, all of these methods are accessors. But what kind of accessors are they? Are they producers or observers? I hope the answer is fairly obvious here. I won't do a pause and think slide, but I will give you 5 seconds to take a breath and collect your thoughts while you convince yourself which methods are producers and which are observers. 5 seconds starting from now. Okay, all of these methods belong to the string class, so if any of them return a string object, they're producers. Otherwise, they're observers. Both concat and toUpperCase are producers, and the rest are observers. So with Liskov, we get a categorization that effectively breaks up accessors into producers and observers. This distinction seems to be especially useful for immutable classes like string, where all methods are accessors to begin with. And actually, that's not an accident. This is a direct quote from Liskov. Mutators play the same role in mutable types that producers play in immutable ones. What does she mean by that? Well, let's look at an example. The push method in a stack type is mutable. It adds an element to the current stack object, thereby changing the state of that object. If someone said to you, "We need a stack type, but we don't want a mutable stack, we want an immutable stack," is it possible to take a mutable type and turn it into an immutable type? It turns out that it is, and it's not too difficult either. You just take all the mutator methods and turn them into non-mutator methods or accessor methods. Can you see how to do that with this push method? Go ahead and pause the video now and see if you can figure it out. Okay, the push method is mutable. It modifies the stack object by pushing an element onto it. We need a method that does not modify the stack object. But for the method to make sense, we also need access to a stack object that is the same as the original stack, except that it has that extra element. Therefore, what we're going to do is return a new stack with the extra element. And here's our signature for that. The original stack is not modified, but the stack returned has the extra element. So this method is not a mutator. Instead, this is a producer method. Okay, so we've talked in this video mainly about the distinction between accessor methods and mutator methods. That's the primary distinction you know. We've also talked a bit about getters and setters. And we took a short diversion into observers and producers. But before we end the video, there's one more question that we have to answer. That question is why? Why do we need to know this? And how is knowing the distinction between accessors and mutators going to make us better Java programmers? And that is a great question. I'm going to try to give you some compelling answers. First, the notion of accessors and mutators are all over the place in computer science. Databases have the basic CRUD operations: create, read, update, and destroy. Reads provide access to the data, and updates mutate the data. The distinction between reads and writes is important to database maintainers. Since most of the time people just want to access information, reads are much more common. Database load balancing patterns will take advantage of this distinction. File systems keep track of read, write, execute permissions on files. Without this distinction, maintaining security would be even more challenging than it is today. There are many more examples. The observer pattern distinguishes between producers and consumers. Web servers distinguish between a GET request and a POST request. And I'm sure you can find even more examples if you think about it for a while. There are times when you are writing code that you should only use accessors. In if conditions and while conditions, you should not change the state of the program by using mutators. The same is true of assertions in unit testing. And of course, no mutators are allowed in an immutable class. Since accessors don't change anything, they're easier to reason about. This is one of the reasons that Joshua Bloch tells us in his famous book, Effective Java, to minimize mutability. Make a class immutable unless you have a very good reason to make it mutable. Finally, the whole distinction between immutable and mutable objects is related to the distinction between functional languages and imperative languages. Functional languages encourage immutable objects. In fact, pure functional languages prohibit mutable objects. Imperative languages make it easy to create mutable types. So they give you more flexibility, but the code also tends to be more difficult to reason about. So what do you need to take away from this discussion? First and foremost, you need to know that accessors read information and mutators modify objects. You also need to know that getters get property values and setters set them. When you hear other Java programmers talk about both getters and setters as accessor methods, you should know that they are not using accessor in the same sense that we are using it here. The programmers who do this probably work with Java beans. You should understand that there are other method categorizations out there, but you don't have to worry too much about what they are. I personally think that Liskov's operation categories are very useful and relevant, but if you start talking about observers versus producers to other Java programmers, you're probably going to get a lot of blank stares. Finally, remember that immutable classes do not have mutator methods, because even one mutator makes the class mutable. And that's it for this Java shortcut on accessor methods versus mutator methods. If you're interested in learning more about some of the topics we covered here, you might want to take a look at one or even all of these great books. Thanks for watching. I'll see you in the next video.